robot arms are huge. Right now.
Big business. Everyone loves arms.
Everybody loves humanoids too.
Yeah.
But my favorite emerging type of startup is the arms in a box startup.
So like manufacturing work cell, but it looks like just a set
but
of
it's
arms
just two arms in a box, or one arm in a box in some cases.
Why is this your favorite? Because they've been around a long time. Arm in a box.
Arm in a box has been around a lot. I had no idea.
Have you never been to a factory?
You know what? Have I ever been to a factory? I don't know if I've ever been to a factory.
So you can
I don't know if I should admit that on podcast. I'm trying to think. I've been to I don't know.
You can do a tour of Tesla Fremont, or you used to be able to. I believe you still can. You can just go do a tour. You should.
I've watched how it's made. Okay.
Strange parts as well.
Strange parts. Oh my gosh. We
love Strange Parts.
We should give a shout out to Strange Parts. Strange Parts is this guy who tours factories in China.
Yeah. He's awesome too.
Yeah. Oh, a fantastic guy.
Yeah.
Now living on a ranch and doing ranch stuff, I think.
He just dropped a new video on, I think it might have been JLC's machining service. I'm trying to remember, but I haven't watched it yet. I just saw it come out. So he's clearly back in Shenzhen, at least to some capacity.
And these are fantastic videos just because the factories. I saw one. It was for like a 3D printer, but not really a 3D printer. It's like it's kind of like it puts a layer, like a thick layer of kind of what feels like paint on things, but it gives it texture and color. So definitely a very different kind of thing, but you can print on anything. That's
like a UV printer.
Yes, a UV printer, that's the word. And he did this tour, and I was blown away because these people were still crowdfunding, but they had such an efficient line set up already for manufacturing this thing. And I was just blown away. Like, what an exciting future where these lines can be set up quickly for something that hasn't even finished its crowdfunding campaign.
Was this arms in a box crowdfunding campaign?
No, it wasn't arms in a box. It was a UV printer. But arms in the box is also fantastic. Although I don't think you need to go to crowdfunding because VCs are happy to back arms in a box.
Well, interesting. I'm curious why, and I assume the answer is AI, as it usually is these days.
Yeah. So arms in a box, the theory is you can give it some design intent, like take the components out of the cardboard box and put them on the pick and place tray or something like that.
Okay.
And it will just do that thing. It needs no programming or instruction. And because the arms are inside of a box, it is ostensibly safe. They can only cause chaos within their box.
The chaos is limited.
The chaos is limited.
Yeah, interesting.
It's not, there's tons of companies in San Francisco doing it, but they're all over the place. These companies that are basically taking LLMs and then using what Meta calls a world model, I believe, that basically can translate text into robot actions and has some kind of closed form loop around that so that it doesn't go crazy.
Yeah, interesting.
Yeah.
So they're using this world model from Meta. Is this direct, or does Meta create this world model and you can just get it, or is this a concept?
That's a great question. I'm going to look up what world models have been released because I'm not sure if any of them are released, but Meta showcases their it working with robotic arms. So the application is a lot of robotics.
Yeah. I'm not sure we can continue to call them LLMs because at this point, if, as we were discussing before, they have spatial reasoning, they have direct audio capability as well. Obviously, there's the text. That's a huge one. And then on top of it, you've got sort of spatial reasoning, and it seems like almost motion reasoning, which I would kind of bucket a little bit separately, right? There's a distinction between, being able to balance and move and manipulate an object and being able to understand how things fit together. For example, they're entangled, just as audio and text are, but they're not quite the same thing. Yeah. So if you have this, it's kind of a motion model is how I would think of it. My theory, I think I've said this before on the show, but my theory with LLMs is that and you see this with human evolution, this vast acceleration, our capability to create societal structure and technology, basically, including, you could argue it's societal technology. It's vastly accelerated, and it's been this big hockey stick, but it's been over the last couple of 100,000 years. And my thesis is that it took us a heck of a long time to come up with an efficient, almost instruction set of our language, and come up with a good way to abstract concepts. And it was very quick to train a child in human evolutionary terms on that instruction set, and they grab it and can run with it really effectively. But we've basically bestowed this tens or hundreds of thousands of years evolution of our instruction set directly into AI in order to bootstrap its intelligence. And so we've basically created an instruction set for heuristic, non-deterministic, stochastic machines. We've given it to them, and they've been able to learn insanely fast because of it. And that's why the language is at the center of these models.
Yep. So one quick thing. Meta did release the artifacts of the model, so presumably the weights. It's called the VJEPA world model.
The VJEPA world model.
Yeah.
Okay.
So and supposedly I don't know its full capabilities, but world models, they're hot.
Okay. And you can just basically pipe that out. The premise being you can pipe its output into a robot. And
a lot of people are saying, you replace a lot of basically control loops. That's what they're saying anyway, with a loop with this model, and it actually can figure everything out. So I don't know how true that really is. Yeah. That sounds a little crazy to me, but that's what people are saying. But on that note, with sort of the bootstrapping of these models, what Meta and or not so much Meta, but what OpenAI and Anthropic have kind of said is that it's not that important for there to be data out there, existing data for this kind of like paradigm you're trying to create, which is not what anyone expected. So there was a recent interview and somebody, I can't source any of this, but somebody from OpenAI, I believe, was talking, and they were basically saying financial companies thought they had all this leverage and we would need their data to train really advanced models. And it turns out just simulating things, validating them is super, super valuable. And then constructing synthetic data is so enormously valuable that as long as you have sort of a really good simulation system, as long as you can create your data, the existing data out there is not as valuable as we move forward, because you can just create so much synthetic data.
Yeah.
So, and most of the models now, I believe they're basically being created against synthetic data sets.
Which is incredible, because we needed the first data to bootstrap that, right? We pulled the whole internet plus a whole bunch of tagging and improvement data, and now we're using the largest existing models to train the next generation and to distill them.
It's kind of crazy how like all human effort, like so much human effort of just putting information on the internet and having the internet be cheap and people just writing comments on the internet contributed to this bootstrapping this massive process.
It was imperative to bootstrap it. It's probably, I think, the only reasonable way to describe it. You couldn't have done it without.
I mean, we barely did it, right? Like LLMs were so bad at first. It's still crazy. I mean, the whole OpenAI story is so crazy just because it was pretty bad. I could not see value in generative models.
When?
Like I'm talking GPT-2, even GPT-3. I never thought it would code. I thought it could autocomplete for me. I didn't think it could code entire features.
Baby steps, my friend. Autocomplete's just the same way or the next way to everything from the ground up.
And you know what? This is where VCs, VCs who have spoken to me more recently. This is what you've got wrong. Yeah, it's going to happen so fast. The wave of AI into electronics, it's going to be mind-bending. You're like, oh, it can only generate LED matrices. And then you'll be like, oh, it can only generate like motherboards. And then it'll be like, oh, it can only
generate radar installation.
It's gonna happen so quick. It's so hamstrung by the tools. It's insane.
Yeah, it's an interesting one, because I think that there seem to be classes of problems that it's true and it's not true about whether or not you can bootstrap it from synthetic data, right? So with the robotics models, Newtonian physics, for example, is not only well defined, right, which the physics of electronics typically are quite well defined as well, but they're also extremely simple. So to create a kinetic model and a to create a kinetic model of, I don't know, a robot arm is a triviality off which we've been running industrial robot arms for decades.
Yeah.
We know how much torque each joint is going to see from each position and each range of motion and in trying to reach what position and all of that type of stuff. And the objective functions are fairly well definable or often definable. Collision avoidance becomes a bit trickier with, voluminous objects and all sorts of things.
Yeah, that's true.
But exceptionally well defined. The thing is, the language side never was. Like, what is a good response or a bad response was all done by human tagging to bootstrap the LLMs in the first place, because even after you trained a base model on all of the internet ever, it would just recite what seemed to be internet-like out of that, let alone what's actually a good response to a helpful chatbot.
Right. So like the argument here, and it's a good argument. Nobody knows the answer to this, but you can't bootstrap like basically like text to mechanical models right now. But I think like what we're like what the crazy thing or the crazy realization that's causing so much acceleration in AI right now is a lot about the difference between AI's generating capacity, its ability to generate like code or things that work, and its ability to judge. There's this huge discrepancy there. It's really good at judging.
Yeah.
It's not so good. It lags on generating.
Bluntly, so are humans. This is a really interesting facet of, I think, people, and actually a big rift between people who can get shit done, bluntly, and those who sit on the sidelines. And it's whether you can exclusively judge, which is the easy part, or whether you can actually synthesize and generate something novel.
100%.
It's anything, bluntly. It doesn't even have to be novel. If you can do anything.
If you can do anything fast. But I think that discrepancy is the superpower here, because if you define a constraint, sort of a constraint system or a modeling system, something like electronics as code, but for CAD, and it is comprehensive, you can bootstrap the synthetic data set just by asking the LLM to judge it. Like, did you capture everything? And the LLM's going to come up with all these reasons why it's wrong and stuff like that. And I think, given enough time, the bootstrapping is much slower, but that initial, modeling the internet and all of that can be essentially repurposed for these things. So
I do wonder if it'll judge accurately enough. Maybe to train like a model to approximate, like, for example, if you say, hey, judge this layout, and you're like, whatever, there are way too many vias and this and that, that might be good enough to get a model to do a better layout. And that's the bootstrapping means you're talking about. That's
basically what I'm talking about. Yeah. Yep. So in the case of PCB layout, like you have one AI that generates it and one AI that judges it.
Yeah.
And you sort of use that to improve it. I think it's a slow process, but with how fast the compute is going, I think that eventually could work. Basically.
Yep. Yeah. It's a funny thing. It's not necessarily It's always a case in life. If there's an endpoint that you think can work, or if there's a solution to a problem you think can work, but there's no path to get to that solution, you're just as screwed as that solution not existing. And it's a little bit the same if you want to take it one further derivative on that positional introspection. It's the time. And at the moment, how quickly the world is moving, it's not really about whether or not you can do something, because bluntly, my biggest problem with the world at the moment, or the world of technology and engineering, is not how we can build stuff. It's what we should build. And I think we've reached that point, which is so exciting. That's really cool. Yeah. Engineering, or the world is your oyster. You can build whatever you like. Now what? But are you going to be able to build that new layout AI faster than someone else who definitely wants it? Because this is obviously something that should exist.
Yeah, absolutely. Yeah, my sort of within like web-based electronics, there's not a ton of people contesting it.
No.
So like, and so within this sort of domain, I'm like, well, is somebody building a web alternative? If not, like, in my crazy deranged philosophy, there will have to exist a web version at some point, which is deranged.
It's a small community, and we happen to know a lot of the people involved. Even in the modern ecosystem of electronics design tools, it's a small world.
Yeah.
You know, and even if you take the web out of it, which it's I guess basically TSCircuit.
Yeah.
Even if you look at the slightly broader question of how many people are in the space.
How many people are doing electronics as code? It's not many people. Yeah.
No, we've met them.
Yeah, we met him. We know almost everybody here, which is it's crazy. It's so small. Every day, I expect like 10 YC startups to be announced that are doing this. Like I would expect. I think they took it off their request for startups. They had it on there for a brief time, like
designing electronics with code.
I think it was designing electronics, designing physical world things, or chips. They might be a little bit chip obsessed too. But yeah, you would think that there would just be like they would fund a bunch of companies every single batch to do this because it's so important.
It's an interesting one though, because you know we've got a interesting perspective, and I do agree with that perspective because you know you got to bet on yourself, of course.
Right.
But as the world is an enormous place, there is an insane number of problems to solve, right? To improve the world in, you know, if you think about this as like a blob with some surface area, to push at the surface of this blob a little bit further. And as the complexity of the world increases, there are only more problems to solve, you know, more useful ways to improve what we're currently doing.
That's true. I mean, we wouldn't dream of doing stuff in electronics as code if
we didn't have food.
If everybody didn't have food. I was thinking even if LLMs weren't out there to write the code.
Well, we were, my friend, because we've been working on this for many years before the LLMs.
It's been a long time.
Yeah.
I was telling Matt the first line ostensibly of TSCircuit. It actually wasn't TSCircuit at the time. It was JSCircuit because I didn't know that TypeScript would be another thing at the time called Flow. Which was, really dating myself. But basically, when React was announced, I was immediately like, this would be great for electronics. And it wasn't until many, many years later that it was even feasibly possible to create sort of an electronics kernel around it because React was still very immature. And everything sucked.
And it was only a few years after that it made sense to build a company around it now because we were discussing this earlier too, but we've given LLMs access to every software endpoint you could think of, and now it's time to give them access to the real world.
Right.
And robotics are one effector of that, but as soon as it comes to manufacturing, you need to be able to design things to actually make new products. And TSCircuit and Atopile are two ways you can do that.
Get in there.
Two of the few ways, we should say.
Yeah. I'm curious what... I've thought about the Atopile or TSCircuit equivalent in 3D kind of CAD.
Yep.
Even in assembly.
Yep.
But I don't know how it starts to look in manufacturing.
Yeah.
It's so different.
This is so interesting. This is why I brought up what I did before.
Yeah.
Because my first startup was building CNC machines that were as easy to use as 3D printers. And so you would give basically a 3D model and you would say, hey, make me this part out of whatever, this 6061 aluminium, and you put the block in the machine, you come back 20 minutes later and you have your part, right?
Yeah.
The goal being, the rapid prototyping and whatnot, but it came from a place where we'd been machining all our own parts and, running the CNC machine, making the cam myself after having designed the parts, and et cetera.
Yeah, that's a lot of work.
And so I grew up with that understanding of actually how the manufacturing processes work as a fundamental of, can I make this thing?
Yeah.
And if you want an illustrative mentality of this, Stuff Made Here is a great YouTube channel because he demonstrates this this design orientation of like, how can I actually build this being a fundamental part of prototyping oriented design exceptionally well, like better than no one else, I think, which is really cool. Or super fast Matt, he's good too. He's great too. But this type of thinking was pretty innate. And when you're thinking about things in those terms, you suddenly try go use a CAM program, which is the software used to generate the path the CNC machine will follow to actually cut that part, make that part. And all of a sudden you go, well, we designed this backwards. You should have thought about this part in context of how can I remove material from a block rather than what should the final geometry look like. You think of it in constraints. And Fusion 360, a CAD program from Autodesk that has built-in CAM capabilities as well as generative design, you can do this and say, I have this surface must be exactly like this because it's interfacing to another part, and I've got this constrained geometry over here, and it can't go outside of this block.
Right.
Generate me a part that can be made by CNC machining that fits with these bounds.
Really?
And generate.
Have you used this? Is it good?
It can be useful. That's the funny thing. I don't use it as much as I probably should. Is the interesting part of this, and that's a good place to be, because it means that there's probably value there according to the experts.
Yeah.
But it's not quite reached its level of maturity yet. But if you can provide an interface for AI to interact with a system like that, that's like the expert system that knows how to do the manufacturing processes, and the AI should be able to interact with the constraints and say, here's what the constraint set looks like, then you can resolve it down to manufacturing. So I actually think we're quite close, but you need to fundamentally change how engineering is done for mechies as well as EEs.
So I'm like a cultist for React, right? So keep me coming from this perspective, consider it from this perspective. But like, I kind of feel like I think of the definite future we're going to reach as like Tony Stark talking to his AI and getting physical things. Will these legacy, that means you necessarily have this kind of voice interface, right? And
ideally, I much prefer it.
Right. And what I've noticed with AI tools is a lot of times I only start using them, we're trying it out. The cost of trying it out is just so damn low, you know? It's like you write one, I've been using OpenAI Codex quite a bit, their web interface. So you can type a prompt to a repo and it opens a PR. That's it. And a lot of times I would go file an issue, do all the work. I've noticed it actually takes less time to ask Codex to do something than to file an issue. And many times it's correct. So all this is leading up to these legacy companies, Autodesk, will they be the owners of this AI future? Like, can they really adapt their software to go all the way back? And maybe one reason they can't is because it would drive design costs to zero, right?
It would play with the tool cost. It's there's another interesting question in that as well, because in my opinion, Dassault Systems and Autodesk particularly have underinvested, and actually and Siemens as well with NX. They have vastly underinvested in the quality of their software. And, so as a professional software engineer, you obviously understand that there's difference between software that achieves some kind of outcome and software that you can actually, what we would consider good quality software, which you can actually manipulate effectively, quickly, add new features to, stack on top of other things, remix in a litany of ways, all that type of stuff. Yeah. So, for example, it's my understanding that some of the core of these CAD kernels and the solvers that drive them, they actually have constraint engines in them as well.
That's right.
Is still in Fortran and single-threaded.
Oop.
And single-threaded, and just like the same, like SolidWorks is only on Windows, and they've apparently, I've heard at least, tried to port it to Mac a few times, and it just didn't really work.
Yeah.
And all that type of thing. And so you're talking about companies with thousands of engineers as well, right?
Right.
So these are serious companies, and their core IP is very, very good in a sense that you can achieve the things that you need to, whatever the advanced surface modeling in Dassault Systems makes SolidWorks, but also CATIA, the more professional, high-end variant of it that I haven't personally used, but you can give apparently constraint sets to CATIA that you just couldn't dream of in SolidWorks, and it'll pop out
I didn't know that.
perfectly contoured surface model, et cetera, that meets all of those parameters and those constraints, which is exceptionally useful if you're designing whatever aircraft or automotive bodies that need to be beautiful and modeled in certain ways and all that type of stuff. So this all matters, right? Like these core IP matters, but the part of the question is whether or not these companies are going to be able to move fast enough using that core IP into this new space if their core IP is not necessarily janky, but just using such old technologies that the ecosystem of support and compiler support and all that type of stuff just isn't really there.
Yeah, absolutely. And the cost of compute is also relevant here because software just gets slower as it gets older.
It seems to.
There's not too many counter examples of that. Most kernels are decades old at this point.
Yeah.
Written in Fortran or whatever. And even if they have highly optimized procedures, there are just crazy developments that happen that change the need to even do these procedures.
Like multi-threading.
Multi-threading is a great example.
You know,
there's a guy, I think some PhD out of some university, created this thing called Manifold, Manifold JS, and it's a Boolean operation engine, but it just uses completely different math. And as a result, it's like 100x or 1000x faster for tons and tons of different Boolean operations for things. And my point isn't that, Manifold could replace these. These are complicated engines, but there are new techniques that come out that change everything. Yeah, and decades old kernels are not going to have those techniques.
Yeah. Totally.
So a question I have, I think about a lot is there going to be a new open source CAD kernel? Right now,
another one, or
so right now there's OpenCascade.
Yes. Yep.
That's basically it.
Yeah.
Are we going to be, are we going to be frozen with OpenCascade, or can somebody now use AI to do that PhD level math to get a new kernel out?
It's an interesting question. So there's also, I don't actually know where zoo.dev have got to. Are you familiar with Zoo as well?
Yeah. So zoo.dev, I think they're text-to-CAD, but they're also kind of like a full sort of 3D
They also
CAD
do
tool.
code-to-CAD. They have
they have code. Oh yeah, they have a language and stuff too.
Yeah. I also don't know if, for example, OpenCascade have their own CAD kernel.
They use OpenCascade,
They do?
I believe.
Okay.
Yeah.
And FreeCAD, I believe, uses OpenCascade.
Yes, I believe that's true.
Yeah. Look, I'm not going to be, I'm not going to pretend that I'm a sufficient expert in exactly where all of these open CAD kernels are at and the quality of them, and actually really, really nuts and bolts how much that matters. Because that's perhaps one of the more important questions. So I can't honestly answer that.
Yeah.
But what I can say is that since, in my opinion, a paradigm shift is going to be what creates like the really next generation type of tooling, where you're starting to think about things from different orientations.
Yeah.
A lot of that modeling becomes less relevant to some degree, if that makes sense. Mm-hmm. Where you might, today you end up with all of these, you have parametric modeling, and then you'll, there's a more appropriate term for it actually, but there's the CAD models you typically think of when you do parametric modeling. Then you've got this Blender-esque either, there's a B-spline modeling,
meshy,
and then there's,
I don't know what to call it.
Mesh models. Thank you. And you end up with mesh models. And part of the issue here is that, at least in my opinion, none of the tools have done a good job of mixing these types of models effectively, or these modeling techniques within a single part. Because, for example, you have as I said before, I think this type of generative design, if done exceptionally well, will be how you get to that Tony Stark-esque future.
Yeah.
But the center of the generative model is almost definitely a mesh, or at least the tesseracts, I'm missing. Are you
thinking of like NURBS? You know, there's like there's all these different words for how to represent
tetrahedrons. Sorry, not tesseracts. What am I talking?
Tetrahedrons.
There you go. I was like, that's not the right word. No, not quite. The NURBS modeling is sort of par for the course with all of this, but you need to be able to combine these modeling techniques well, because you're going to end up with these sort of current CAD kernel style models for the interfaces, because a person's basically drawing them, and you're saying, we have just agreed to standardize upon this thing as it is, right? I literally do this. Like, that's one of the one of the ways to think about the models. Literally do this in one side, and then you're going to want to composite that, with some mesh models, which lend much better, for example, to these optimizers that can do the generative modeling.
Yeah.
And so being able to combine the two is not something I've seen done well. And I think that demands, or plausibly demands, a new kernel to do really efficiently.
Yeah. I hope somebody does it. I think what I found with building the auto router is some of the hardest, like, PhD level problems. You can basically get somebody to help walk you through them. And that's very, very valuable.
By someone, do you mean O3?
I mean O3, yeah. It can walk you through it. And so, like, I think it's there. I've also looked at OpenCascade, and, like, it's definitely written decades ago. And it's like, I don't know. It's probably fairly usable, but I just, like, I look at it and I go, oh man, I feel like simple. There's something to be said for a kernel with a good API, and how much that'll enable AI to just build off of it and create things.
No, I think all of that, as you point out as well, as AI gets better and these problems are well defined, then building a new kernel, the cost of building a new kernel drops. And actually, Zoo has done that. They've built a new CAD kernel.
Yeah,
and that's a big part of their pitch. So it's clear that at least some people think this is an imperative part of what's coming next. And I think...
Would you use Zoo? Like, and you might know the founders personally.
I do know the founders.
Okay, so then it's kind of a tough question to answer. Because so they have a custom language, right? For CAD modeling. Yeah. Do you think, like, it can kind of... tackle fusion-y things for you? It's a difficult question to answer, honestly. By the way, I got you some water out of it.
Yeah, well, thank you.
This guy just dry throating my extended period here. I was like, we could cut this into two, but then it's too late. I have to go after this.
Do I think would I use it? So I tried Zoo the other day. I tried their text-to-CAD, and it didn't work for a 422 unprocessable entity HTTP error.
Oh, I see.
So that was a very simple...
Reliability is a big deal, right? You don't want to get your design trapped in something you can't get it out of.
No, you definitely don't. And I do think that's the openness, which, both TSCircuit and Atopile care deeply about.
Yeah.
But do I think I would use it? I'd like to give it a crack. I think that one of the things that's really hard is that without fundamentally changing the mode with which you interact with these, which isn't just a text, like text is existed for a long time with, like, OpenCascade, for example. By mode, I mean, like, the way that you think about your models. Without changing that orientation to, like, the subtractive manufacturing or manufacturing first thinking or any of those things, then at the end it's just another boundary geometry modeling tool.
This is the problem with OpenCascade, in my opinion, is it really is just a geometry tool rather than a it doesn't. I don't think OpenCascade supports constraints, which, like, it falls into the XY kind of problem, but now it's not an LLM experiencing it, it's you experiencing it, doing a bunch of math and stuff like that to figure out where the XY positions are.
It gives you a bit of a riddle. So the constraints are one big step from basic XY kind of maths. Give the constraint engine, let it solve the problem for you. That's definitely one example. But would I switch to text-to-CAD if I said if I had to type, like, manufacture with 3-axis CNC machining, 3 orientations, orientation 1, waterline machining, remove all of the material you can, bearing pocket, spoked something, like, whatever, just, like, pick your description. If I could access it like that, then, like, sure, like, that sounds great. But while I'm typing out geometry instructions, it doesn't provide me that, like, kind of necessary leap I have to switch the mode of thinking.
It needs to get much closer to that sort of Tony Stark reality before it's going to be feasible. And even with, like, ChatGPT memory, it could, instead of you saying the 3-axis machine, it might just know that that's your preference, right? So it's just spitting out stuff you love, that it knows you have a setup at it for the factory you use, or the not factory. What do you call these people who CNC quickly for you?
Prototyping house.
Prototyping house.
Machinist.
Yeah, machinist. Yeah, exactly. I don't know.
It's gonna vary. Yeah, no, it's an interesting future though. I think it was a big part of it was actually some of the impetus for starting Atopile as well was actually trying to work out how to think about designs differently. It wasn't actually coming from like, well, what if we did it with text? It was like, well, no. The things that you actually think about in a design are a layer deeper. They're the relationships between components.
Yep.
They're the topology of your circuit. They're the like high level stuff. And there's like, what's the best way to bring these concepts together? And that's when we went, well, you could use code. That's the easiest interface I can think of for these higher level concepts. And that's how we got to that answer rather than the other way around.
Yeah.
And so I think
it's not like text is that important. We stumbled into that.
Yeah. The text isn't the important bit of using the text.
Yeah.
Yeah. No, absolutely.
That's how it always works though with these companies that pop off is they were doing something before it was obvious, you know? And I don't think we knew that LLMs were going to be amazing and that they needed text, but that's what happened. And for every company too, I think with Zoo didn't start during the AI revolution.
No, they started before it as well.
Yeah, exactly. So it's like every company that bet on blank as code gets to sort of ride the wave.
I think actually there's something like fundamental there is if you start a company on a basis of like first principles, what is the best way to achieve something?
Yeah.
Then you're going to be relevant in whatever future turns up. It's being prepared for the unpreparable, the unknown unknowns.
Yep.
So,
yep. Absolutely.
Yeah. Seve, great talking to you, my friend.
Yes, we'll leave our beautiful office here. Thank you, 43, for allowing us to use your awesome room. All right, see you next week, man.
See you next week.